Let's talk about arc length. In this video, we're going to solve the problem you see on the screen. Find the length of the curve 1/6 x cubed plus 1 over 2x on the interval 1 to 2. So we start with our standard arc length formula for the length of the curve. So the a and the b here are the 1 and the 2, that's the interval. And then our integrand is the square root of 1 plus the derivative squared. All right, so before I plug stuff in, I'm just going to take an additional step. Instead of y, I'll call my function f of x so that it fits here perfectly. The 1/6 x cubed is fine, but for derivative purposes, it might be useful to write 1 over 2x as 1/2 x to the negative 1. In fact, as scratch work, we could always compute the derivative separately and then simplify it. So our derivative here will be 1/6 times 3x squared minus 1/2 x to the negative 2. So that gives us 1/2 x squared minus 1 over 2x squared. So this is my derivative formula, and that's what I'm going to plug in for f prime of x for the arc length. All right, so let's get started. Arc length equals the integral from 1 to 2, because that's my interval of x values. Big square root 1 plus, and then my whole derivative formula. Oh, yeah, that's a minus 1 over 2x squared. Derivative formula squared dx. Okay, so our job from here on out is to actually compute this definite integral, which is not a simple task. Some of these, the function at the beginning is simple enough that this is like a normal antiderivative step. But this is one of the tougher ones where you have to work pretty hard to get the antiderivative. Okay, so we'll start by actually multiplying out 1/2 x squared minus 1 over 2x squared squared. And we do have a shortcut. If you have a minus b squared, that's always a squared minus 2ab plus b squared. And if it's a plus, which we'll need later, it's the same formula, but all three terms are positive. I'm going to keep this in the integral. 1 plus. All right, so 1/2 x squared is my a, so I'll have a squared minus 2 times a times b plus b squared. All right, this is pretty messy, but we can definitely simplify this center term from the multiplication. So right up front, I have 2.5, those are gone. And then I also have an x squared and a downstairs x squared that can cancel. So from this entire center term, the only thing that survives is just a 1/2. I'll take a separate step and put that in on its own, just to stay organized. Okay, so this doesn't look great, but it's at least better than the line above it. And then there's one little bit of simplification that we can do to combine like terms. So we have a 1 here and a minus 1/2 here, so they'll combine to a positive 1/2. And I'm going to strategically put that positive 1/2 between the two other terms. So essentially this 1 will disappear and this will switch to a plus 1/2. Okay, so we've done all the simplifying we can, and this is typically where we get stuck because this still looks pretty impossible to compute. But the key is these multiplication like FOIL shortcuts up here. This is almost identical to what we got when we did a minus b squared. It's the exact same three terms, but with a plus sign right here. So if this is that minus that squared, then all this is this plus that squared. So we can take everything under the square root and kind of refactor it, even though it's a funky looking function. We can still make it 1/2 x squared plus 1 over 2x squared squared. And the magic there, of course, is that the square root and the square can cancel. Technically, they cancel to an absolute value, but both of these terms are always positive, so we don't have to worry about that. And we have just 1/2 x squared plus 1 over 2x squared left as our integrand. So we still have work to do, but at least we can see how this antiderivative is going to happen. Right, so I have a regular reverse power rule over here. This is 1/2 x to the -2. So its antiderivative is 1 over -1 x to the -1. And of course, I'm evaluating from 1 to 2. So with a 2 in it, I have 1 over 6, 2 cubed, minus 1 over 2 times 2. And then we'll repeat that with the 1 in it. We'll combine our fractions. This should come out to 13 over 12 over here, just making a common denominator and subtracting. And then for the other one, we get minus -1/3. So we combine them into 13 plus 4 is 17 over 12. And that's my final answer.